In a previous lesson, we talked about application architecture. We talked about the different layers within a typical application architecture, the presentation, domain, persistence layers. There might be other layers too, but those are the three that typically are in most business style applications. And up to this point, we have not been able to persist data because we haven't talked about how to do that. What technologies do we use? What products do we use? And so what I want to do in the next few lessons is to give you a single easy way to work with data in your applications. Now we're going to devote an entire in fact, several different courses to data access. The next data access course that you'll come across after you finish this series is going to be called the Data Persistence Fundamentals, DPF, I think it was. And we'll talk about many different styles of data access, the different technologies that are available from the Microsoft platform, how you would go about accessing the different APIs to work with them programmatically, the differences, the strengths, the weaknesses of each, and so on. But I don't want to talk about all that now. We can't fit it into this lesson. We'll have to table some of that. Again, my purpose here is just to give you one simple way to work with long-term persisted data in your applications. And so what we're going to do, we'll take this in several steps. We're going to create a database, and maybe we'll spend another lesson or two talking about database creation. And then we're going to use a specific API in .NET called the Entity Framework, and we're going to create an entity data model for our application so that we can programmatically access that database. And then finally, we will then access the database programmatically by creating certain objects from that API that allows us to work with the connection to the database. It allows us to work with the data as if it were any series of classes and objects inside of a system that we built. Now, a couple of caveats here. First of all, we're working with the tools in Visual Studio 2013 for this video. I am 100% confident that Visual Studio 2015 will look completely different. How am I so confident of that? Because every time there's a new version of Visual Studio, the data tools change. That has been one of the biggest headaches that I've had, and I'm sure many content providers have had working with Visual Studio in particular. So I'll try to create another version of this for 2015, 2095, whenever, as long as I can continue doing this, we'll try to keep this fresh. The other thing that you need to be aware of is that you'll have to have an add-on installed called SQL Server Data Tools. Now, SQL Server Data Tools can be downloaded and installed separate from Visual Studio. However, if you're working with Visual Studio Express, Visual Studio 2013 Express for Web, you already have the SQL Server Data Tools installed. If you have Visual Studio 2013 Community Edition, you might have the SQL Server Data Tools installed if you selected that option during installation. The same is true for Professional, Premium, and Ultimate. On the screen right now, you can see a picture of the install process for Ultimate, and one of the options there is the check mark to say what pieces of the puzzle do I want installed in Visual Studio. And so if you did not check the SQL Server Data Tools, then it won't be available to you in Visual Studio. You're going to need to download the file. You can find it from this URL and hopefully get it installed correctly. But again, that's not the purpose of this lesson. If you don't already have it installed, there will be a whole other course that will really lay some of the groundwork to help you get it installed, understand what you're doing, what's a relational database, what's a non-relational database, how do you design them, things of that nature. Okay, enough caveats. Let's jump into this. So as you can see, I currently have a project that I'm working with, Local DB Example. And I've done nothing here except add a new default.aspx page to my application. Now, the thing that I want to do first is talk about Local DB. There are many different editions of SQL Server. LocalDB is an edition of SQL Server intended for software developers to be used on their local desktops. SQL Server is a server product much like Exchange Mail or SharePoint or any type or Internet Information Services, where you have the software installed on a centralized server inside of your company's network, or in the cloud. In the case of Microsoft Azure, you can host your SQL Server database there as well. But at any rate, it's more of a service, a network service, rather than it is something that you would keep local on your own desktop. So by allowing developers to create local DBs, it's a less feature-rich version of SQL Server. It's for personal purposes only. You can't make any outside connections from another user's computer on the same network to the developer's computer in order to access the data, things of that nature. There's also no replication features and some of the more robust features that are required in a enterprise scenario for SQL Server. They're just not available in LocalDB, but that's fine. For our purposes, that's perfect. Once we develop our application in LocalDB, SQL Server LocalDB, then we can script it out and we can run it against a testing and a production database server that will be used for our testers and our end users respectively. We'll talk about full lifecycle software development later on. Okay, but at any rate, what I want to do is add a new database to Visual Studio. So there's a couple different ways to do this. Unfortunately, when I right-click, it's going to go off to the right-hand side of the screen. So what I'll do is just select LocalDB in the Solution Explorer, and then I'm going to go up to Project and click Add New Item. And in the templates on the left, I want to make sure to select Data. You can see I've already looked at this dialog a few times today already. So it's selected here. So Visual C# and Data templates. And the first template that we want to use is a SQL Server database. And so I'm going to give this the name Acme, A-C-M-E, just a fake company name where we're going to store data. Now we get a warning right up front that you're attempting to add a special type of file, a database file, to your project, and they suggest that you put it in an app data folder. It's a special folder inside of your Visual Studio project that is intended to be used for your database. And I don't want to explain all the ramifications of that now. In this case, I just want you to go ahead and click Yes. All right, so after a moment, an app data folder will contain an acme.mdf and an acme_log.ldf. Again, I don't want to talk about the difference between those two files, just except for the fact that they actually are created for you when we take those steps. The next thing that I want to do is connect to the database and start designing a table in order to save data into. And you can think of a table in isolation like an Excel spreadsheet where you have columns and rows. So we're going to design the columns, and then each row of data that will add to that particular table will represent one instance with all of those columns that we can fill out for that particular instance, that particular row of data. So what I'll do is just right click and select Open, and notice that it pops me into the Server Explorer and it creates a data connection to our acme.mdf. See that little green electrical plug? Now if for some reason we lose a connection to that local database, you'll see a little red circle with an X in it, I think. So just be aware that if something's not quite working right, make sure that your connection from your project to the local DB in the Server Explorer is still working. So there are lots of different kinds of objects that can be stored inside of a database file. What we're most interested in is creating a table. Again, a table is a repository for rows. We'll design the columns of a table, and then we can start adding data as rows to that table. So here again, I'm going to select it, and I'm going to right-click and select Add New Table. And this will open up the SQL Server Data Tools Designer for tables. And it has some interesting parts, some of which we'll talk about now and some of which we'll leave for later. You have an actual property designer in the upper left-hand corner. You have kind of an overview or a preview of some of the key properties of the table, and then you have the actual script that's being generated every time that we make a modification inside of the property window. Now, if you are a database professional, you could probably go straight to the T-SQL tab here at the bottom of the designer, and you could just type it in instead of having to rely on a third-party set or this tool set in order to create it for you. Some people can type Transact SQL just like we can type C# now, you and I. So the one thing that we're going to need to do is actually change the name of the table. So where it says table here, I want you to highlight that and type in the word customers. Okay? So that'll be the first big change that we make. And now you can see that in the tab, it's dbo.customers, and we're still in design mode. Great. So what I'm going to do is I'm going to change ID to a customer ID. So this will be a unique identifier in our database that will identify one customer and differentiate it from other customers. So there might be several different Bob Tabors in our database, but they'll be differentiated by their customer ID. Okay? And we have some choices as to what we want to make an identifier. We can use integers and just let let SQL Server automatically add or increment the current row customer ID number by 1 each time we add a new record to our customers table. However, we've already been talking about GUIDs, globally unique identifiers. So there's a different data type for this column that we'll want to use instead, and that is the unique identifier column, which is close to the bottom here. So this will allow us to use GUIDs as our unique identifiers for rows in our table. All right, the next column over is whether or not we should allow nulls. Now, when you're working with a key, a primary key of a table, like we are here, and I don't want to talk about this too much, but basically, if we're going to count on the customer ID being the way that we can always access a unique customer in our system, then we can't allow that column to be null, because if there were several nulls, 2 rows that were null, we wouldn't be able to differentiate those 2 rows by their customer ID. They wouldn't have a customer ID, they would be essentially equivalent. So for the most part, we do not want to allow nulls in most of our data, with a few rare exceptions. We'll come back to the default, but say, for example, I wanted to create a default value. Maybe it's the state or the country that my data will be inserted into as I insert my data. Then I might want to use the string USA or UK or wherever I'm from, or wherever the application is based. So let's go ahead and add a few more fields of information. For example, I'm going to add a name, and I'm going to make this a varchar 50. Think of a varchar as a data type that can accept Unicode characters. So if you're writing in kanji or some other language that has different characters than the alphanumeric characters in the English language, then we would still be able to store those characters here in this field of information. The 50 is how many characters worth of data that we're willing to store. The var keyword, or the var word, means that if we don't need all 50 characters for a given person's name, then it will only use the amount of characters to store that particular person's name plus 1 character, which is kind of an identifier to say how long that that particular string in the database is. Again, kind of a technical detail. Let's just ignore it for now. We're only going to work with unique identifiers, varchar 50, and a varchar max here in just a moment. Here too, I don't want to allow nulls. It wouldn't make sense to have a customer without a name. And we're going to continue on here with address, varchar 50. We will not allow nulls. City. You can see as I'm typing these in and making selections that it's adding to that script, that table creation script below the designer. City, state. Now ideally we would choose the right data type for the kind of data that we're saving. So for example, a postal code, it may not require, maybe there's no country in the world that would have a potential of 50 characters for a postal code, but we're going to go ahead and leave that now. But you typically would want to refine the type of data, restrict the type of data by choosing the right data type and the number of characters or the precision of that data. And then finally, we'll just type in the word notes, and this is just going to be a free-form field that anybody in our company can type into just to make notes about their relationship with this particular customer. And I'm going to choose varchar max, which means we could literally save pages and pages and pages and pages of data about a particular user, and we would not be restricted from doing so. Whereas with varchar 50 or varchar 1000 or varchar 5000, we would be restricted to just 5,000 characters. All right, so that's the basic difference between varchar with a new number and varchar max, which would give us the ability to store virtually any amount of data. In this case, I'm going to go ahead and allow nulls to be present so that we don't have to add notes to a new customer in order to add them to the database. Now, there's one other thing that we can do here is that we want to make sure that no matter what, whenever we type in a new customer, they have a GUID in the correct format. So what I can do is use a built-in method to SQL Server called newID, which will ensure that if we don't supply a GUID whenever we create a new customer, one will be created for us. So I'm going to do newID, open and close parentheses, and I'll hit the Enter key on the keyboard, and you can see that now it added this default newID to our script. All right, so I think that's about all that we wanted to do here. If I hit the Save button right now, what it will do is try to save that SQL script. In other words, it'll try to save all of this that we just typed in to a script file inside of our project here. And if we were treating this as a real project and we wanted to store the scripts so that we can rerun them against a different database, whether in staging or production environment, then we may want to do that. But for now, we don't want to save this script to a file. All we really want to do is click this Update button in the upper left-hand corner of the tab in order to apply this new table change or to create this new table in our database. Here in this dialog, it asks, are you sure that you want to do this? I'm going to go ahead and click Yes, Update the database, and we'll either get a success or failure based on everything that we're attempting to do. And a little green box with a check mark in it means that it was successful. And so now if we were to get rid of that and we were to close that down and we were to go back to our Server Explorer and expand it, we can now see that we have a customers table. Let me right click the customers table and select Show Table Data. So at this point we have no data in our table. We've just basically created the structure that the data or the shape of the data should take. But now we can type in data right here into this designer window. So I could go like Bob and 123 East Main Street, and we'll put them in Chicago, Illinois, 60450, I don't know. And I'm just going to leave the notes field blank, and I'm going to hit Enter on my keyboard. And when I do, notice that it goes to the next line. It creates another line for me. I can create another record if I want. One thing might be a little concerning at first. Customer ID says the word null, but didn't we say it couldn't be null, and didn't we say that by default it should have a GUID in it? Yes. All we simply need to do there is just refresh the view by either clicking Shift-Alt-R or choosing the little refresh button on that toolbar, and now you can see that there's a nice juicy customer ID, a GUID representing Bob in our database. Okay. All right, so I think that's enough for this lesson. We created a database, a local DB, a developer-only version of SQL Server so that we can create our application locally, and then once we're confident that it's working, we can deploy it out for testing purposes and staging or out to the end user in a production environment. We've created columns. In each column, we define the data type, whether it should allow nulls. We talked about the default setting for a given column. We didn't really talk about what a primary key was, and you remember you might see a little key off to the left-hand side. Those are some issues that we'll talk about in that data persistence fundamentals course. I don't want to get too deep into this. For right now, we're just going to create one table of data, and we're going to work with that from this point on. So we also looked at the Server Explorer and how to tell if you have a connection and how to work with your database using the SQL Server data tools that you can install separately from Visual Studio, but you probably installed them whenever you installed Visual Studio originally, unless you deselected some options during install for the Community Edition or any of the paid editions. And I think that's all that I had to say here. So now in the next lesson, what we want to do is begin the process of being able to access this database from our C# code. So we'll do that in the next module. We'll see you there. Thanks.